Hello, my name is Andrew Bowman. I'm a CS grad student at RIT, and today I'll show you a tool and a language I developed for algorithmic composition with formal grammars for music. Just a quick note, you don't need to know anything about music theory or formal grammars or turtles to understand this, so I'll just briefly introduce them. Turtles, if you're not familiar, the turtles I'm referring to at least are a educational tool that's often used for beginner programmers to understand procedural programming, such as so like you're given an environment where you can give a turtle which is like a cursor or a pen, instructions to move forward, back, left, and right, and draw lines. So it's just kind of an educational tool with instructions. And in terms of formal grammars, I'll be talking about CFGs, a special kind of CFG, but in general, formal grammars are just a grammar has an alphabet which has terminals and non-terminals, and it also has a number of rules or production rules, as I'll refer to them. So you can see over here, these are a couple of production rules, and on the left of a production rule is a non-terminal, and it's replaced with what we call a string, which is just like a list of symbols, and these can be non-terminals or terminals. And so generally the way we use CFGs is to recognize strings. So you can start with one of the non-terminals or terminals, any of the symbols, like S, for example, and you would replace the non-terminals with based on the production rules. So you could replace S with either the first or the second production rule. So in this case, we'll do it with the first, and you can see this is the resulting string that the formal grammar quote unquote recognizes. And if you use the first production rule a couple more times, you end up with this longer string. And if you use the second production rule, then you get these like 3A's, 3B's. And you can use this, for example, to recognize languages like on the left, where you have the same number of A's, or a number of A's followed by the same number of B's. I'll get into why that's important later. So Lindenmeyer systems are a type of formal grammar that are a specialization of CFGs where you simultaneously replace all the non-terminals at the same time. So it kind of happen in layers of iteration, where you start with an axiom, that's like your starting symbol. For example, down here, and you can see if you replace 0 with the string, then you get like the first iteration. And if you use the rules again to replace every non-terminal, which is ones and zeros, with the rules, then you get the next string after an iteration. And what you can do is reinterpret these symbols instead of just terminals and non-terminals as instructions for a turtle, for example, like we saw earlier. So if you consider that 1 and 0 might be instructions for forward and backward, and brackets might be instructions for left and right, then you can instruct turtles after doing a number of iterations and replacements on your string to generate cool fractal-like pictures, is what they're often used for. They're often used for also modeling cell life and like biological systems in general, and kind of fractal things. But today I'm going to show you how you could use it to compose music. First, the reason why you might want to compose music with L systems is that, for example, many algorithmic music composition methods use a lot of randomness, and for example, Markov models, it's like a lot of random transitions, and it can be kind of hard to guarantee or enforce certain structures or long-term ideas. So for example, if you want to have an idea repeated at the very beginning and the very end of a musical piece or fragment, it can be very hard to ensure that. It can also be hard to constrain the length of the composition, which is completely alleviated by having like tree-like structures of replacement with your production rules. So you can see like one way to use grammars to compose is by using like hierarchical structures to kind of enforce these constraints. In addition, you can also use this pattern to reuse musical fragments that you compose. So for example, if you have a musical fragment or an idea that is repeated throughout a piece, it's easier to kind of non-destructively transform and replace that and add it in new places. So next I'll get into the language I actually created for like specifying these grammars. And if you want, you can pause here and check out the actual concrete syntax. But for now, I'm just going to get into examples so you can quickly understand. Here I show, this is the language and syntax for like creating a grammar. And so once you kind of pass this through the tool, it will compose like music basically using your grammar after a number of iterations and replacements, as I discussed earlier. So the first line, you just give the axiom, which is the starting symbol, and then it's just followed by a number of production rules. So here we see one very simple example production rule where you're replacing the symbol S with a single terminal. In this case, I use terminals to represent like musical notes and so forth. And in order to play musical notes, you need a few components. Like you need to know what the pitch is, what the volume is, how long to play it, stuff like that. So that's what these parts are. The terminals are started by a colon, and then they're followed by the octave, the pitch, an accidental optionally, which can be flat or sharp. And the pitch, by the way, is just a note like on the piano. So it'd be like A through G. And then optional timing as well, which is like the number of beats. It just defaults to 1. So I'll show you some more examples so you can understand how this language gets used. Here's another like one level of indirection with rules. So if you start with S and you replace using the production rule for S, you get an A. Replace A, then you get a note. So A in the 4th octave. Here's another one with a couple or a layer of indirection. As you can see, you can use recursive production rules. So specify the right side in terms of the symbol that is replacing. So in this case, you can see if you keep iterating on this on the string, you get long strings of just A's, repeated A's. Here's another example about how you might create a baseline for a song with a kind of hierarchical structure like I showed earlier. So you can see you have the highest part would be the axiom, and then it's split into 3 broad sections, and each section has kind of like 4 chords, and these chords correspond to like a number of notes. So you can use that to kind of structure chord progressions or basslines. There's also a couple other forms in the language besides just replacement and non-terminals and terminals. And these are kind of the non-destructive, transformative like wrappers you can put around musical fragments like I discussed earlier. And so there's a few of them. You can like repeat a fragment. So for example, if you use this non-terminal A-2 times, it would replace to be 2 times A. And then when this string has all its parts replaced, the ×2 and the brackets are unaffected, and A is replaced by its rules. So you get basically this string twice, and then those are replaced, and so on. So you can get very non-destructive repetition of musical fragment. You can do the same thing for changing the speed, reversing it, or transposing it up or down. Yeah, this is more of that. The last form is just concurrency. So obviously at some points you might want to play 2 notes at the same time. So all you have to do for this is use this bracket syntax with the pipes to separate just strings. and those strings will play starting and ending at the same time. A note about this is like the timing variant is enforced strictly, so the time for all the parts playing at the same time must be exactly the same. So I'll give you a couple examples of compositions, or model a couple of compositions using this like formal grammar approach, so you can see how it might be useful. So for the first one I'll start with is a backing track with like a drum set. So this is just something called a funk beat I found online. I'll display it for you here so you get an idea of what it sounds like. So yeah, that's all it is. There's 3 instruments. You can see sometimes they're playing at the same time, and they're also playing like opposite each other. But one thing about backing tracks and percussion in general is that a lot of times it's used for consistency, you know, helps you keep you on beat, but you will also want to have variations, not just playing the same thing over and over again. You want to have slight variations sometimes, especially leading into a new section. So I'll just propose that take this measure, and instead of using this measure every time, maybe every 4th measure I'll use this variant which I created, which is just scrapping the second half and replacing it with these 4 snare beats, just to give it a little variation. So in total, it would look like this. You have your normal variation 1 for 3 measures, and then variation 2 for 1 measure. And so this is how I would model the variation 1 measure with the grammars. There's a couple of syntax items I didn't really introduce here, but they're pretty simple. This one is just for instruments. This one is just for changing volume. And the colon underscore is just for rests. They work the same as other terminals. And not all the rules are shown. You can see here you could just use compose things like I showed earlier by layering those parts together to create this beat. So since I'm using my own instruments, it won't sound exactly the same, but I'll show you how it sounds. And if you're curious, I'm using a software called LMMS, which is open source and free for synthesizing. And so in order to continue to make the rest of the variation, I ended up splitting my original composition of the 1 measure into 2 halves, which I call, you know, like base 1, base 2. And then the base variation 1 would be composed of base 1 and base 2, which is the regular one. But base variation 2, for example, would be composed of base 1 and rests for the bass, because this is just snare. But you could see I'll kind of put those 2 parts together differently for variation 2. And then to combine it all together, I'll merely repeat the first variation 3 times and then follow it up by the second variation, as you can see here. And it sounds like this. Two, 3, 4. And then you can see how it continue on. Another case I'll show you is Bach's Prelude in C major. This piece kind of stood out to me because there's a lot of repetition. The rhythmic pattern is exactly the same throughout the whole piece, but the tones, the pitches shift throughout many keys, but the rhythm pattern stays the same. So I'll show you how I might model this with a formal grammar. Also, as a side note, I thought of later that Philip Glass might also be really easy to model with grammars. So here I identified a bunch of parts that are exactly the same. So everything in the same color box is exactly the same kind of musical fragment. And so these are pieces that I would turn into their own like music strings and non-terminals and kind of replace them in multiple places to make it easier to model this. And obviously, my goal is just to model this to show you how it might be useful. but you can see how you can use this pattern and the structure to create other compositions. So I just started modeling the first few measures. I did complete them, but I don't really have time to show them all. It just sounds like Bach's Prelude in C major. If you'd like to listen to it, you can go ahead and find it somewhere. It's very popular. And great. Yeah, that's all for Bach's Prelude in C major. You can you can see how it's easy to repeat multiple parts. For example, I have CE here and CE here, but I might put that into its own non-terminal to change it later. I'll talk about some other things I did with Bach's Prelude that aren't shown in this slideshow. For fun, I put them on top of each other. It's pretty easy. You just kind of repeat the funk beat as much as you need for Bach's Prelude and speed up or slow down as necessary. Really just a copy and paste operation. And sounds like this. So that's all for that. I hope you enjoyed those compositions. Another few notes I'd like to make is that the tool is like extremely precise with musical timing. All the timing is based on fractions and rational numbers. So when you're measuring timing of notes, for example, they're exactly to the fraction. I went with this approach because I know a lot of software uses like kind of a floating point time or number of seconds, and you have to go ahead and quantize everything. And I just didn't like that approach because there's sometimes you want to know exactly how long a piece of music is, and I want to go with like music theory first approach. Also, there's opportunities to procedurally generate music. I showed way in the beginning you could use multiple production rules for the same non-terminal, but not in the samples. But you can use multiple production rules for the same non-terminal, and when it does its parallel replacement or parallel rewriting, it can choose production rules randomly to replace, and so that can enable you to procedurally generate music. Also, because the structure and the syntax of the language is so simple, there's opportunities for metaprogramming. I spent some time writing rules with Bach's Prelude to kind of reorder the measures in a way that might be fun or go on forever, based on the chord changes and like the harmonic differences between them. And it's really easy to just generate several hundred rules and use those for your composition benefit. And additionally, it also works using a MIDI interface, so you can, the instrument synthesis is separate from the like composition and the rules and everything, so you can produce your own music the way you would like. There's a few issues, kind of. Other approaches to this kind of composition that have been done in the past usually use intervals instead of notes. So instead of your terminals being an exact note, it'd be like moving up or down by a certain amount, which can be really useful because then transposition isn't really necessary, and you can move around your musical fragments as needed. Also, just like the syntax for composing is a little clunky. Probably prefer to like import a MIDI file or something like that. And also the notes, like the volumes in terms of actual expression, are pretty limited. Obviously, it's just kind of an on and off, which is not really useful for a lot of kinds of music. Yeah, there's a couple challenges just implementing the system, especially with the precise music timing. And in the future, I would hope to improve the tool by, like I said, being able to import MIDI, for example, or making a note editor to make it easier to generate those like small musical fragments, and also probably build in a system to generate chords for convenience, because it would be nice to be able to specify like A minor, for example, and not have to write all the notes by hand. If you'd like to see the tool or the source code or use it, you can find it at that link. Thank you.